Good evening, Namaste. I am Chandrakanta Rathore, coordinator for this session. A very warm welcome to the TSTSI Tech Deep Dive 2024, Session 4, Security and Privacy. Before we begin, I would like to highlight a few hygiene instructions for ensuring the smooth running of this session. All attendees will be kept on mute throughout the session by default. If you have any questions for the speakers, please type them in a Q&A tab. You may interact with fellow attendees live using the chat tab during the session. If you want to enlarge your own screen presentation, please click the expanding arrow icon on the top right of the presenting screen. The tool is configured for HD video. The attendees may switch to LD in case you are facing any bandwidth issue. This webinar is being recorded and will be posted to the TSTSI website within the next few days. Attendees may like to visit the exhibit booth of TSTSI in between the sessions to know more about our work. Attendees can use the lounge facility for networking. The lounge will remain open till the end of the conference. Now, I would like to introduce the convener of this session, Mr. Vijay Madan. Mr. Madan is currently associated with TSTSI as advisor and mentor with special focus on standardization in services and solutions relating to evolving technologies and applications, vertical sector use cases, security and crypto, IoT, drone services, cloud computing, PPDR, future ICT enabling systems, also with JWG's focus connected with 1M2M, 3GPP, and ITUT. Now I invite Mr. Vijay Madan to introduce the session co-chairs. Sir.
Thank you. My thanks to the distinguished chairs. My thanks to the distinguished panel. My welcome to all the audience. We are already starting with a century in attendance. And I would like to introduce the new panelists and first of all, the chairs. And chairs will introduce the panelists. Chairs, please. Next slide, please. So the distinguished panelists are Mr. Amit Sethi, TCS India, and Dr. N. Subramaniam from SETS, which is the Security Organization of India. Mr. Amit is an experienced person, expert, and specialist, specializes in network services domain. He leads the team focused on Industry 4.0, amongst many others portfolios, development on 5G private networks. And I am reading only for the sake of time the first couple of lines and all that. And similarly, Dr. Subramaniam is serving as executive director. He's head of the SETS since December 2022. Prior to joining SETS, he had served at Center of Development of of Advanced Computing, CDAC, Pune, and as head of senior director corporate R&D. I have known both and interacted with Mr. Amit Sethi and Dr. Subramaniam and seen their indulgence, their involvement, and I have met them on many occasions, and their responsiveness and team building as well as their technical expertise. Over to you, chairs. Thank you.
Thank you, Mr. Madan. It's indeed a great pleasure in joining the TSTSI team in welcoming all the participants and audience. We take this opportunity to welcome the esteemed panel members, panel chairs, as well as the individual panel members. It's an opportunity. Between me and Mr. Amit, we were just brainstorming about this topic once TSTSI had approached us, and we found that this is very apt and important topic when you talk about 6G at its early stage, to look into aspects of evolving technological context around and try to build this kind of session. Accordingly, we kind of went ahead and discussed with all the panel experts, and we have organized this whole session for next 2 hours, which is going to be interesting. on two major directions. One primarily coming from the evolving technological aspects on quantum communication side, and also on the post-quantum cryptography. This is what is going to be dwelt in the first panel. We have esteemed panel speakers. We'll be introducing them. We had the next thread of discussion as panel 2, which will be moderated by Mr. Amit. And here we would dwell upon the end-to-end core network security aspects with when you talk about 5G plus and 6G evolving context, including zero trust architecture, how AI can be enabling control panel, and quite a lot of interesting stuff over there. So with this kind of an overview, we had this panel organized. To start with panel 1, we have this overall coverage where we have this evolving scenario. One from the new algorithmic perspective, since when Shor had postulated that the evolving quantum computing paradigm is going to be threatening the existing certain crypto systems, that are integer factorization based and things like that. And there are global efforts that are happening to devise newer primitives that I'm sure our experts will be talking about to develop the post-quantum crypto primitives. And this is very important in the context of 6G, because in 5G, again, we have various protocols and security measures like TLS, IPsec kind of primitives, which uses a traditional classical crypto system that is being currently used, which may need to be relooked at in this context. The second trajectory of this particular panel that would be looking into is more from the quantum mechanics front, where we have the evolving secure communication primitive that's kind of assuring you a secure channel and a key distribution in a very seamless, effective way. And how does this aid the evolving 6G communication as well? This is going to be largely the kind of focus in the first panel. And going ahead, I think we will look into the second panel. Now, I take this opportunity with this brief about this panel in introducing our panel members. We are thankful to all the experts and esteemed panel members. Firstly, to Professor Anil Prabhakar from IIT Madras. So Professor Anil Prabhakar received his PhD in 1997 from CMU with a dissertation on nonlinear spin wave optical interactions. He has been with the faculty at Department of Electronics, Electrical Engineering at IIT Madras, and we have been closely from SETS working under his leadership in establishing the quantum communication channel between IIT Madras and SETS, involving Education Research Network, CDAC Bangalore, and other agencies. So it would be very interesting, and it's our pleasure to have Professor Anil here as the panel chair, and I'm sure that he will have you'll be sharing his deep insights in it. I'm going further. We are also having Dr. Anindita. Dr. Anindita Banerjee is a senior scientist and project manager at CDAC Pune, and she's working in the area of quantum technology. She has earlier worked as quantum research head and VP at QNU Lab, focusing on quantum safe solutions for cybersecurity. Take this opportunity to welcome Dr. Anindita. And we also have with us Mr. Prashant from CDOT, who is currently working as scientist and group leader in CDOT, Delhi. He has about 28 years of work experience in telecommunications R&D area, in which over the years he has worked in various capacity and led projects. Specifically, I understand there have been key contributions by him along with other members for TSDSI in this specific area of PQC context of evolving 5G plus IO. Welcome, Dr. Prashant, for this panel. And we have with us Dr. Vipin Rathi, who is the CTO of Synergy Quantum. He is also an assistant professor at University of Delhi. He is vice chair and individual board of directors at Open Infra Foundation. He is chairperson of Linux Foundation, Hyperledger Telecom Special Interest Group. We have been interacting with him for various other purposes of collaboration, and it is interesting to have you over here, Dr. Vipin. And I think with this introduction, we have esteemed members from academia, R&D lab, government, as well as industry. So I'm sure that this panel for the next 40 minutes or so would be making their viewpoints and bringing forth the opportunities and challenges to be addressed, and the roadmap as a country, what we should be doing next. And we are looking forward to interesting discussions and Q&A kind of session. So with this, I would take this opportunity to invite Professor Anil to give us keynote address first, and then we can go take it further. Thank you. Over to you, Professor Anil.
Intervene. The second panel will start in next less than 1 hour, much less than 1 hour. And in second panel, we have again experts, and which will be introduced by the moderator and chair in that channel, that session, subsection, you can say, Mr. Amit Sethi. So this is the first panel. Thank you.
Okay, thank you very much for that kind introduction and inviting me to chair this panel. As the panel chair, I will try not to steal the thunder of all the speakers on the panel, and I will only attempt to give you a overview of what I think is relevant for us to discuss. And in doing so, I hope to seed questions that the audience might have, and the panel members could then ask, and we could answer, right? So with that in mind, let me share my screen and get started. Okay. Sorry. Okay. So what we're talking about, as Dr. Subbu mentioned, is quantum key distribution, and I took the liberty of saying or post-quantum cryptography. Okay. Hopefully before the end of this talk or this panel itself, you will be in a position to ask the question whether you should be investing in quantum key distribution or you should be investing in post-quantum cryptography for the purposes of 6G. And the panelists should be able to help you give the answer to that. Right? What we're talking about primarily is security of data in transit. So with the advent of 6G, we're going to have a lot of data from different sensors, different modalities being transmitted. And the security of this data is something that worries people like me and others who worry about cryptography. Right? In very simplistic terms, this cartoon out here tells you what the problem is, that today we are using what is called a public key cryptography, where there's a public key and a secret key. And the public key is used to encrypt data, and the secret key decrypts data. And in the middle, there is an eavesdropper. And that eavesdropper could be passive, who we call Eve, or it could be an malicious eavesdropper, an active attacker, and that's called Mallory, right? A lot of people will always ask me to find suitable Indian names for these characters: Alice, Bob, Eve, and Mallory. I'll confess we haven't yet done that, and it also doesn't flow quite as easily as these names. At the bottom of the cartoon is something else, which we're showing you in another form, that you have a plain text, that you have an encryption key, a ciphertext, and a decryption key. Right? A lot of the security depends on the transfer of this key, and it's not very clear how the key is getting transferred. And once the keys are transferred, if you look at the security assessment threat today and this came out in 2023, so it's already probably old, you'll see that it takes a hacker to brute force your password anywhere from a few seconds to a few minutes, unless you are particularly conscious and have a very complicated password of numbers, upper and lower letters and symbols, in which case you probably won't remember the password yourself and you'll end up writing it down. And that becomes insecure, right? So most of us, if we use numbers, upper and lower cases, and maybe a symbol or so, about 10 characters, are vulnerable to about in 2 weeks to today's AI ML systems, right? Now, this light came out in 2023. Before that, we used to always argue that we needed to worry about our encryption technologies or our key distribution for other reasons. And that was because this was the advent of quantum computers. And the quantum computers would make our today's encryption, which is using the RSA standard, insecure as soon as we hit about 10,000 qubits. Well, it turned out that, of course, with the AI and ML coming in, we didn't have to wait till quantum computers with 10,000 qubits came in. We were vulnerable even today. If you look at the quantum computers, the argument was that you needed 10,000 qubits, and in 2023, they already had 1,000 qubits publicly announced. It is likely that private players, non-state actors, and states themselves may have access to more than 1,000 qubits. So we will not know that our infrastructure is insecure. So when you're building a 6G infrastructure, which we expect to roll out, let's say in 2030, you're better off planning for the advent of more powerful classical AI ML, as well as the availability of quantum computers. So how do we do quantum secure communications? Is using sort of the properties of quantum mechanics. And the idea is that if you use the properties of quantum mechanics, even if you have a quantum computer, you cannot break someone's password, or the key is not vulnerable. And we use a particular property called entanglement of a pair of particles. So you can imagine that if I have a photon, I have it either as a horizontal photon or a vertical photon, which in this case would be an up particle and a down particle. And we transfer information on these particles. So we write a little 1 or a 0 on one of these particles and send it out. And based on the information that is received, you can then set up a symmetric private key. Now, sending entanglement particles is a slow process, and nature does not always help us. And so people have other protocols. One of them is called the prepare and measure, which is easier to implement in practice. And there we use two basis sets, which are horizontal and vertical, and 45 and 135 degrees. And we split the information into either the basis set and the values. So the value could be either 0, which is horizontal, or 1, which is vertical, or it could be 45 degrees and 135 degrees, depending on the basis set that is chosen. So you're, in some sense, you split the information into a basis and a value. And the other property that we rely on is that you cannot clone a single photon. So if you have a photon coming into a beam splitter, you cannot arbitrarily get two photons out. You violate the principles of quantum mechanics, which so far have not been violated. So this is how we do quantum secure communications. We use these kind of principles of quantum mechanics, and in doing so, we say that you will beat the quantum computer. Sorry about this. So in entanglement-based quantum key distribution, we are looking at a particular idea that there is an eavesdropper who is eavesdropping on both the quantum channel and the classical channel, but the entangled source has two particles which are entangled, and they're transmitted towards the two sides. Now, if there is a horizontal photon that reaches Alice, and there is a vertical photon that reaches Bob, then Alice knows that she's got a 0 and Bob knows he's got a 1. But because these are correlated, If it was reversed and Alice got a 1 and Bob got a 0, or Alice got a vertical and Bob got a horizontal photon, then they would get a 1 and a 0. So the keys are very easy to establish, right? This sort of scheme is very easy to understand for people who believe in entangled photon sources. It's a whole new lecture on how we generate such photons themselves. If you look at quantum key distribution, we have a certain level of systems that come into place. You are looking at two parties who are communicating either on free space at 805 nanometer or optical fibers at 1.55 microns. So for 6G, we expect a lot of it to be fiber on the backhaul, and optical fiber will be available. We set up these quantum channels, and we also need the classical channels. You don't need two fibers. You can do them on the same fiber using what is known as wavelength division multiplexing. But more importantly, you also have these classical communication steps of authentication, key shifting, error correction, and privacy amplification that one does. So a lot of people think that quantum key distribution is a lot of quantum mechanics. I keep reminding them that it's also 90% of it is also just classical telecommunications and information theory, right? So you'll see error correction and privacy amplification. Once you set up the key, then you have the encryptors and decryptors that are there on either side. And there the channels can be as high as 100 gigabits per second. There is a caveat here. If you look at the two numbers, top right is 100 kilobits per second, bottom is 100 gigabits per second. There is a factor of 1 million between the two. In very layman terms, you can assume that you're using a password a million times. And that, again, sets up an insecurity. So one has to be aware of these little loopholes, and when we say that we are fully quantum secure. This is the plan for the National Quantum Mission, is to set up intercity quantum key distribution over 2,000 kilometers with trusted nodes on existing optical fiber, and also have a multi-node quantum network with quantum memories, entanglement swapping, quantum repeaters, and so on. Last but not the least is going to be post-quantum cryptography. And I will explain in a little bit why post-quantum is also required. On the bottom right, you'll understand where the limitation of quantum communications is. Point-to-point links can go only up to about 200 to 250 kilometers without what is known as a quantum repeater. But actually, we do not know how to build a quantum repeater today as yet in a reliable fashion. So most people will use repeaters at some kind. Also, if you go to very long distances, you'll see that the rate keeps dropping on a log scale. However, for a metro area, we are looking at maybe 30 kilometers or 50 kilometers links. If you're looking at 6G stations, they're probably a few kilometers, and you can very easily do a form of quantum key distribution in metro areas. This is actually one of our examples of a metro area. We have boxes set up at IIT Madras, at the IIT Madras Research Park, at the Society for Electronic Transaction Security. And actually, this has been extended by another 15 kilometers further into the city to hook up onto the National Informatics Center. So this sort of network acts as a test bed for us, where we test different kinds of protocols. We test clock synchronizations, picosecond clocks, which again might be useful when you get to 6G technology, right? And then, of course, we are planning to hook up the cities. So this is an example of Chennai to Bangalore. And when we do that, we are going to be using chips. At the bottom right is some of our first chips that are coming out. That will enable us to do a link like this from Chennai to Bangalore using what we call secure nodes, right? Something like this is part of the National Quantum Mission, and we are supposed to hook up Bangalore all the way to Delhi. So hopefully you will see and hear more of it in the coming years. Last but not the least, right, post-quantum cryptography. And I pulled this particular slide of Apple's website, and you'll see that they're already implementing what is known as PQ3 for iMessage. So in classical cryptography, you have no end-to-end encryption by default, or you may have WhatsApp or Signal that use end-to-end encryption by default. In post-quantum cryptography, you have to establish a key and those keys are being established using some standards. The National Institute for Science and Technology, NIST, in the USA put out a competition, and there are maybe 3 or 4 contenders. One of them is dilithium, one of them is Kyber. They have different use cases, and I think you'll hear more of it from the panel. And then, of course, you have to use this encryption to do your regular transmission of ciphertext, right? So it's easier to implement. It's a software solution, but we do not know if it is secured in the way we can rely on quantum mechanics to secure it. It's again still a mathematical form of hardness. So I'm going to end here by saying it's not a question of quantum key distribution or post-quantum cryptography. It's more a question of and. Both of them serve different purposes. And as you'll hear from my next speaker, Dr. Anandita, she'll tell you more about the quantum key distribution, and thereafter you'll hear more about post-quantum cryptography. So the take-home message is it's not an or for 6G, it should really be an and. So let me stop here and request Anandita to take over the presentation.
Yeah, thank you, Dr. Anil. I think nicely placed all the points like the National Quantum Mission Initiative, ongoing ones, and this heated discussion about PQC versus QKD. Yeah, we'll come back to that in the discussion session. Over to Dr. Anindita, please.
Sir, is my screen visible?
Yes.
Yes, it is.
Thank you, sir. Thank you, Chairperson, sir, for aptly setting the context for this session. So let's talk about quantum cryptography, particularly quantum key distribution. So since the word distribution is there, let me clarify that we are in the business of generation of correlated random binary bit stream between two parties who are not co-located in a very secure fashion. And one such application is generation of symmetric encryption keys for a cryptogram. Now, why are we talking about this? Because the computational security is of particularly this model is information theoretic nature, whereas the classical world, the security provided is computationally bound. So we are talking about a very high advanced security, which has no counterpart in the classical world. But if you look at the entire QKD structure, only a very small part, which is very fragile, sensitive, is the quantum part, which we call it as quantum data transfer. Rest, all the processes are classical in nature, and they happen on classical compute hardware. You must have heard from Professor Anil Prabhakar about the protocol nature. Yes, there are two categories. One is you prepare the quantum source, encode it, then you transmit it, can be either in free space, can be either in fiber, and then you decode it at the other side and measure it, and then you interpret the results. So this is prepare and measure that is usually followed. It gives you a higher distance, and the other one is entanglement based. So both have a good security, but of course, when you're talking about entanglement, it gives you a security of another level. But apart from that, even if you do a prepare and measure or entanglement-based protocol, the rest of the processes, sifting, error estimation, error correction, analysis, privacy amplification, secret communication remains the same. Now, why am I putting this up here is look at the levels of how we are actually investigating the matter. We know that the protocol is information theoretic secure. It's on paper. It's a mathematical model is there. But when I'm implementing it on imperfect devices, we already understand how much is the imperfection based on the experimental data. We estimate the leakage. We try to include that in the analysis. We characterize the source. We see how perfect it is with respect to it's in the quantum regime or it's in the classical regime. We look at the security requirements for the protocol. So all this goes into the analysis part. We do an error correction. So error correction is a very important measure, because what happens is, if somebody is trying to perturb the transmission, if somebody is trying to monitor the transmission, then with high chances that gets reflected on the signal transmission, and you can see it in the error rate. It increases drastically. It may or may not increase drastically, depends upon the intelligence of the eavesdropper, how he's performing the attack. We know that there are certain attacks which will not have reflection on the QBER, because we are doing a mathematical modeling of the entire process. So, and we give the power of quantum physics to the adversary, classical physics definitely, but also the quantum physics. So we know what all can happen, and that is taken care of. And a lot of rigorous scientific methods are followed to estimate the security requirements. What are the assumptions taken? And finally, after having calculated the leakages, we enter into a privacy amplification, where we try to increase the information between Alice and Bob and decrease the mutual information between the adversary and the transmitter or the receiver party. And once we receive the secret key, which is of some, say, depends upon what type of QKD you are doing. Usually it's in Mbps, in megabits, and then that goes into the application. Lot of security proofs and have taken place, and lot of maths has been done as how to take the results or the secret key from QKD and apply it to the broader framework of cryptography. So with that, once we have seen, it's not easy to explain everything in 10 minutes, but I try to give you a picture of, what is the QKD architecture, how much is the quantum part, a lot of maths inside it, much of it is in the classical part. Quantum is only when I'm generating, rest when I'm processing it and storing it, it's all classical. With that, we go to the challenges. The challenges here lies with the source, because the way it is generated, if I'm generating an entangled source, the rate is way less, and usually we use weak coherent sources. And there is particularly the amplitude of these weak coherent sources is tied up very closely with the security. It cannot be very high. If it is very less, again, the error rate can be higher. So there has to be identified with lot of analysis. So sources, then basically we use all the classical equipments, because how the quantum particle interacts with the classical devices is interesting. A classical source will interact in a certain manner, but quantum interacts in a different manner and gives rise to the quantum effects. So the modulators, encoders, demodulators remains the same. But when I'm changing the source from classical to quantum, the behavior changes. And then, of course, we have quantum detectors. The quantum detectors are 10% efficient for a particular wavelength, but some of them are 65% efficient, 70% efficient, but none of them is 100% efficient. Okay, so it's a matter of investigation. A lot of R&D work is happening in that area also. We have to take care, that if I'm detecting the quantum sources in one particular degree of freedom, it should not leave a footprint in some other degree of freedom. So this is not a very trivial thing as just saying, yes, I got some detection, but there's a lot more other factors which has to be taken into account. Remember, we are giving the power of quantum to the adversary. So then we come to the imperfect devices, that starting from even a beam splitter, nothing is perfect. And of course, there are losses when it is transmitting from one end to the other end, be it fiber or be it free space. Be it different levels in the atmosphere, because now we are talking about, we are not talking
Sorry to intervene, madam.
We are talking about building platforms for QKD. We are talking about... Sorry to intervene, madam. Yep. Yes, sir. Am I on time? Yes, sir.
Voice is breaking. If you like to switch off your video.
Okay, so is it fine? Is it better now?
Yeah, now better.
Oh, great. Thank you. So I hope my first slide was bringing, the QKD architecture, what it entails, how much is quantum, and the 90% of the part is actually classical, happens on classical hardware. Then I was talking about the challenges of quantum key distribution, right from sources to detectors to anything in between. Nothing is perfect, and you are working in a picowatt level. The optical communication which you do is in milliwatts, but when you go to quantum, it comes to picowatts, and they are very fragile, and the losses are tremendous if they are not accounted for carefully. Distance, commercial QKD systems are it's not more than 100 kilometer, but academic, we keep on exploring the limit. So it will be higher, hundreds of kilometer. Then it also depends upon what type of QKD you're doing. It defines the distance. If you do satellite again, it's a very, you can cover thousands of kilometers. In free space, it is few hundred meters, perhaps, still it's in a very R&D stage. Then you have infrastructure and maintenance cost. Since you have quantum devices, quantum detectors, they have to be kept in a system which is very stable. Temperature, humidity, light, ambient light, everything, and vibration. So depending upon the platform, we are working in CDAC Pune, we are working on an aerial platform. ISRO is working on a satellite platform. Prabhakar sir is working on terrestrial platform. So we have challenges in all these levels. Maintenance, wear and tear, then of course end-to-end security, because if there is something, say you want to transmit a message from Madras to Bangalore, so how do you ensure an end-to-end security? Then if you look at the adversarial attack, most of the attacks in the quantum world translates to a denial of service attack. So how are we going to take care of this particular challenge? It is also a matter of investigation, though HC has pointed some methods of overcoming this. And then, of course, integration over the existing network. That also is a challenge. So a lot of work has been done. The TRL levels of QKD systems are higher than any other domain. It's already in the market, in national market as well as in global market. But having said that, considering the nature, now theoretically everything is information theoretic secure, but when you translate it to the devices, to the real world, in a box, challenges differ from tabletop to the system in a box. So these are the things and many more. And finally, how do we see quantum in 6G? Well, if we look into the vision of 6G, then the security comes from the quantumness, from the quantum security, whether it be QRNG, whether it be PQC, whether it be QKD, whether it be an integrated solution combining the three. We discussed QKD. Basically, it's a business of generating secure symmetric keys. Now, for information theoretic key, you need an information theoretic encryption algorithm. So one-time pad is one such algorithm, but however, we use symmetric AES, and for that, the length of the QKD keys is also not enough. So there are ways to enhance, and the best security would be if you use an OTP and QKD keys. Then there are certain communication where we are not transmitting the keys. I just mentioned here quantum secure direct communication, but another aspect is counterfactual QKD, where you are registering something without actually the quantum signal carrying the information reaching there. So it takes, it enjoys the non-locality aspect property in quantum, and there are so many different nature of QKD protocols or quantum communication protocols. Even teleportation is one of them, and you will see those primitives fit in when we discuss quantum internet. So a quantum internet will encompass everything, right from generation of quantum internet is very different from classical internet. You will have generation of entangled photons, you will be using entangled photons, you will be seeing enhanced, high precision, high sensing, more data processing. So all those things will be there in quantum internet. Then the quantum random number generator definitely gives you very, of course, high entropy, but also it generates information theoretic random numbers. Then you have post-quantum cryptography. So all these components, I have just written 4, but 4 are less. There will be many. They will be absorbed in delivering applications like quantum blockchain. In quantum blockchain, the security part is taken care either by a PQC or by a QKD. We have hybrid quantum network, QKD, QRNG, and PQC. We have quantum internet, which I just told you. It will have a lot of quantum primitive communication protocols like teleportation, entanglement distribution, and several such things, including QKD and etc. And then we have air, ground, space, air, ground, sea integrated network security, which will talk about the terrestrial network, then connecting the terrestrial to the airborne network, drones, and then high altitude platform, maybe perhaps balloons, and from there to satellite. So all this will function in a very integrated manner, in a seamlessly integrated manner. That is how I think we can see quantum coming up, quantum communication coming up in 6G. Definitely computing will also play a very important role, not only from it gives you some, exponential speed ups for some mathematical problems, but high data processing and also it will be consuming less resources as compared to the classical. So I think it's a lot of opportunities. A lot of things will happen when we are talking about quantum in 6G. And with that, I think I rest my case. Thank you. So over to you, Chairperson, sir.
Thank you. Thank you.
Dr. Subbu, thank you, sir. Thank you, sir.
Subbu, do you want, should I?
Go ahead, sir. Go ahead, sir. Kindly go ahead.
Okay. So thank you, Anandita, for that exposition on where the Q in 6G is going to be. And as you mentioned, the opportunities are tremendous. I'll request Mr. Prashant Chugh to speak next.
Good evening, all. Thanks to SDSI for inviting me as a panelist. So it is enlightening to hear you from all. So as we have been told that we need to share our initial views on the subject, and my subject is PQC, so I will share my views in form of the presentation. Just please allow me to share my slides. Hope my slides are visible.
Yeah. Yes.
Yeah. So we have to share our views on PQC in context of 6G. So I strongly believe that PQC is a must for 6G networks, and I go about my views here. So first of all, let us understand briefly an overview of PQC and the standardization. So PQC, or the post-quantum cryptography, it refers to new type of cryptographic algorithms that are being designed to withstand the potential security threat to the conventional cryptography from the advancements in quantum computers. So previous speakers have already laid out the context that these quantum computers, as they are maturing, they are a threat to the classical cryptography, and therefore we need some different methods. So QKD is one method and PQC is the second method. So PQC, it uses mathematical algorithms. Different hard mathematical problems are used rather than the prime number factoring or the problems which have been used in the past. So there are new different set of hard mathematical problems. And in this context, NIST, which is an agency under Department of Commerce, US, which has been standardizing cryptographic algorithms in the past, it started a PQC standardization process in the year 2016, and it gave an open call for proposals. And where subsequent to 3 rounds of rigorous public evaluation, it has released 3 draft PQ standards in August 2023, and final PQC standards are expected from NIST anytime now. So all these, a team of expert cryptographers submitted each proposal, and so many proposals were submitted, and there was a worldwide review by cryptanalysts, and after each round, certain candidates were dropped. And now 3 candidates have been selected in the form of draft standards. So these are 3 draft standards: FIPS 203, commonly known as Crystal Kyber, but the standard name is Module Lattice-Based Key Encapsulation Mechanism, MLKEM. This is used for key exchange. Then Crystals Dilithium, which is the standard named as Module Lattice-Based Digital Signature Standard. And FIPS 205, which is Sphinx, or the Stateless Hash-Based Digital Signature Standard. So all these draft standards have been released, and the public scrutiny period of these draft standards is also over. And anytime, because they said that the final standards will be released in July, so that's why I'm saying that anytime now these final standards can be released. Now, a brief overview of the national and global efforts towards PQC migration. So USA has come out with the National Security Memorandum, which says to prioritize transition to PQC and migrate all federal systems, cryptographic systems, by 2035. And many countries like UK, Germany, Australia have also come out with guidance for PQC migration. And many countries are awaiting for these final standards to be released, and they will come out with guidance and some sort of roadmaps. And most countries are planning to follow NIST final PQC standards. European Telecom Standard Institute, or ETSI, has also released recommendations for migration to PQC, and it advocates hybrid classical / PQC key exchange and certificates. So by hybrid, we means that you combine the classical and the PQC, because you know that the classical has been standardized over the years and has also been used for so many years, and no vulnerabilities have been found, except for that we are saying that when these quantum computer advancements will be there, then it is under threat. And PQC, the standards have evolved over the years, but in practically, when it will be deployed, it can be possible that initially you face some challenges. So they are saying a hybrid, combine the classical and PQC key exchange for key exchange as well as for the certificates. And IETF, whose most standards we have been using in internet and over a number of internet-based communication, it is come out with draft RFCs for transport layer security as well as the IP layer IP security. And these standards also mention about hybrid classical / PQC approach. And with respect to India, Telecom Engineering Center has constituted a working group for preparation of guidelines or report on migration to PQC. And this subject of migration to PQC has also been discussed by various speakers in the previous 2 annual quantum conclaves jointly organized by CDOT, TEC, and TSDSI. Now, coming to our mobile telephoning systems, which are used today quantum safe. So I will say that all the public telephony systems, including all public cellular or mobile telephony systems being used today anywhere in the world, including 4G, 5G advanced systems, are quantum vulnerable. So with respect to it, I would like to point out that 3GPP had released a report in March 2019 on the study on the report of 256-bit algorithms for 5G, in which it had analyzed the threats of quantum computing to 5G. And at that time, it decided that it shall further study the subject after the NIST PQC standards. So as of now, whatever they studied, the threat is there, and all the 5Gs and 4Gs which we are using, they have quantum vulnerable algorithms. With respect to TSDSI also, there is a TR on study of PQC for future 5G networks and application verticals, in which CDOT was also involved in this. And this report analyzed the quantum threat to various security algorithms used in 5G architecture. And in both these reports, a number of quantum vulnerabilities in the algorithms used for confidentiality, integrity, and authentication and availability in 5G architecture have been brought out. And the point is that most of 4G and 5G standards, they use IPsec and TLS at various levels. And the underlying algorithms to IPsec and TLS, the crypto algorithms to underlying to this, all are quantum vulnerable. And they need to be replaced with newer standards. I will also like to point out that GSMA has set up a task force on PQC, and it is known as Post-Quantum Telco Network, PQTN Task Force. It was set up in September 2022 with the objective to support roadmap for PQC and its adoption across global telecommunication supply chain. And the latest white paper, which it released in February, where it has come out with some guidelines as well as some initial set of telco use cases which are impacted by PQC. So if you see those use cases, you find that very prominent cases like IP traffic between RAN and core network, then authentication of all the virtual network functions, then the signing algorithms used in all the firmware updates. That is, when you update a firmware, you sign it for authentication. So all these signing algorithms. Then the VPNs, which are used for managing all the telecom devices or updating the firmware. So all these are vulnerable. And also, when a new SIM is configured, then there is some transfer of root key between the mobile network operator and the SIM vendor. So that process is also vulnerable. And also the remote eSIM provisioning for all IoT, M2M, consumer electronics, and mobile phones, all this is vulnerable. So this they have mentioned about initial telco use cases, and I'm sure we also are analyzing. There are many other use cases which are quantum vulnerable in existing 4G and 5G architectures. So why PQC is a must for 6G networks? So we know that the initial commercial deployments will start in 2030. And what they say that cryptographic quantum computers, that is the quantum computers of such maturity which can have an impact on cryptography, they are sure to be a reality in lifetime of 6G systems. And hence we must act now. And advancements in 6G will lead to proliferation of many additional use cases that mandate secure cryptography in terms of PQC. When we're talking about 6G to be used in terms of high precision surgery and also in autonomous vehicles, V2X communication, massive machine type industrial use cases. And also 6G's focus a lot is on integrated AI and communication, integrated sensing and communication. So a lot of private data is going to be carried over 6G, private data related to health and finance. Even the privacy regulations are becoming stringent across the world, and such many more regulations will come across the world by 2030. So my words from my side is that PQC is a must for 6G networks, and also it is important that 6G security and privacy design needs to include PQC from the beginning. Thank you from my side. I hope I just finished in my time.
Thank you very much, Prashant. You kept to time, which is very helpful. I think we will, there is of course a lot of interest on PQC and its applications to 6G, and you covered it very well. We shall have some time for Q&A, and hopefully we can address some of the questions in the Q&A session. We'll now request Dr. Vipin Rathi to present his thoughts.
I hope my screen is visible, right?
It is.
Yes.
Yeah. So thanks. Thank you so much for inviting me. And before I start, I want to start with quantum communication. So for me, quantum communication deal with three things. One is QRNG, post-quantum cryptography, and QKD. That's what I will talk about today. And first of all, I want to introduce that how we can integrate QRNG in the existing telecom products. For example, on the right side, as you can see, by default, this RDCD is a function in the operating system, whether you're using Ubuntu or or any Windows product. So this PRNG is insecure, we know, but there's a RAN function by default call this operating system, and then you will come up with a PRNG. But if you replace this with the QRNG as a hardware, whether it's a PCI card or one use server, you can integrate this RAN function again with the QRNG thing. So you can use this seed to generate this public private keys, shared secret, and ciphertext. So this is the how you can integrate QRNG in the existing system. So that's what we did, and this is how you can migrate from core. Your core is, let's suppose, 5G core to core, which is quantumized core. In the 5G we have SUPI to SUKI. In 4G there is a thing called IMSI, but there was attack on IMSI catcher things. That's why in 5G they removed this plain text to the ciphertext things. And but currently we are using this elliptic curve kind of things. So that what we have shifted this elliptic curves with the crystal Kyber and the hybrid post quantum mechanism, in which we are using elliptic curve as a session keys and the CAM as well for the post quantum cryptography. Again, we replace this random numbers to generate these seeds to the QRNG, and then the whole SBI communication, because this is a SBI architecture, this 5G things, and internally many cores are using this MTLS. That's what we have replaced with the post-quantum TLS things. And digital certificates, again, as the speakers mentioned, that dilithium is the standard now from the NIST, and that's what we are using. And symmetric key AES 128 that's what in 5G core, many operators still are using this AES 128. According to Grover's, this can be, again, breakable, and it should be upgraded to AES 256. That's what we have done. And then for the N3 part, this is IPsec, should be PQ IPsec, especially for the 6G communications, and DTLS to the post-quantum TTL. So this is the migration steps, how you can migrate your 5G core to the post-quantum core. Next is with the post-quantum cryptography, there are two ways. One is hybrid post-quantum encryption, in which we are using elliptic curves, classical elliptic curves, and with post-quantum algorithms, whether it's a crystal Kyber or other CAM. And then homogeneous one is completely solely depends on post-quantum cryptography algorithms, either Kyber or some other lattice-based cryptography. And currently in the 3GPP, you can find these encryption profiles, which is based on what is your security level. And in future, you will see that because it is not possible only because this is based on the classical cryptography without any QRNG, because the seeds are very, very important, because most of the time we see these kind of hacks happens because of less entropy in these seeds, right? So in this encryption profile, I will show you that how in future you will see in 6G that how they will integrate first QRNG in these type of curves, in the classical curves, and the future to the post-quantum cryptographies as well. And all the internal communication, this SBI things is supplemented by this concept called in 5G called SCP, which is Service Communication Proxy. And we secured this with the PQM TLS, again, hybrid, using hybrid approach, because we can't directly migrate from classical to post-quantum, complete post-quantum. So the best way of this migration is to hybrid ways. So first step is to shift to the hybrid, and then to the complete post-quantum once these all NIST approve all these finalist things. So I think July is the date, and let's see when they will finalize these standard procedures. So you can see these profiles in the future. Currently, AB is the profile, right? Either you can use Curve 2559 or SECP 256 with PRNGs. But again, you can use the same curves with the QRNG as well. And again, in the future, as you can see in the E, the security level is increasing by integrating Kyber with QRNG, and this is the utmost security you can have. So we have this SUKI to SUKI conversion. That's what we are using QRNG and post-quantum cryptographies. So currently, this core is using elliptic curves. That's what we have replaced with, as you can see, encapsulation, decapsulation happens through this CAM, and then this AES-256 is using, we are using AES-256 to conversion of this SUPI to SUKI. And this again 3GPP compliant. Why? Because we are not changing anything except again shifting these algorithms from classical to post-quantum ones. And again, you can integrate this QRNG as left. You can see there are three ways. Either you can use PRNG, either QRNG as a hardware, PCI card, or some server, or even cloud APIs are also available nowadays. So three ways. It depends on your implementation, how you're implementing in the 5G core or beyond 5G. So depend on your need, you can integrate all these things in your existing systems, and then you can migrate as well. So I want to show you that how it works internally, for example, between network functions, how it communicates through NRF and getting these tokens, JWT tokens, to authentication using AES-256. So as you can see, this client hello, server hello happens, and then this server certificate and client certificate also shared between these two network functions. And I want to show you that how these post-quantum certificates we are generating. So again, we are using QRNG and then dilithium to generate these digital sign data, CSR, which is certificate signing request. And this CSR can be now, you can validate using hash values, and then finally these post-quantum certificates will be generated using dilithium. So this is the core part. Now I want to talk about QRAN as well, which is quantumized RAN, and how you can integrate. So before I start, in my way, what I understand is 6G is mostly deals with ORAN because it's vendor neutral, and again, there are a lot of interfaces through which you can get a lot of data, either through near real-time break or non-real-time break in SMO forms. So of course, this split is 7.2, and that's where we implemented this. Our ORAN migration to QRAN migration is from the RRC to the other functions like F1 AP and E1 AP. How you can migrate from classical cryptographies to the post-quantum ones, and this is what we are using post-quantum IPsec and post-quantum TLS to, and using by integrating QRNG as well. So this is the migration and this is again specified by multiple standard bodies, either 3GPP or ORAN. In the ORAN, we have a different working groups, 11 or 4, depends on the interface, or depend on the which either we are talking about DU interface or CU interface kind of things. To summarize this, I want to like how it works, because these ORAN and 3GPP, how these two things are working together to make this whole ecosystem quantum safe. So as you can see, this DU and CU communication can be, we can use post-quantum TLS kind of things. And this is where we are using F1 AP things. And this F1 AP currently is SCTP, which we can replace with the post-quantum DTLS or things like this. And it's not only on the DU-CU part. Of course, you can do with the SMO and near real-time break, or any DApp, whether it's XApp or RF. Or again, if you put a blockchain in it because of like marketplace or smart contracts to deal with this kind of XApps or RFs, that also can be integrated very easily in this kind of architecture. And then you can again integrate post-quantum security in the current ORAN architecture as well. This is the overview, like how it will look like. We can have post-quantum security at the front hole, mid hole, back hole, at the 3 points. Of course, VDU, VCU, again, post-quantum safe. Why? Because again, by integrating QRNG and generating these keygen by using QRNG and applying PQC in the interfaces as well. So that's where you can virtualize your QRAN kind of things. So I want to show you this end-to-end quantum secure connection, how it will look like in 6G kind of things, or even in the 5G or beyond 5G. This is a QRAN, and then the core kind of things, where DUCU you can see is a QRAN, and in the 5G core you can see how we implemented this end-to-end architecture. And the last thing is CubeSec. This is
Yeah, Vipin, we are running out of time. I'm not sure.
We propose the right side. Oh, okay.
Yeah.
Yeah, that's
So
fine. That's
Mhm.
that's
Thank you very much.
Yes.
I think that was very useful. We have actually run out of time for this panel quite completely. Subbu, so do you want to take the microphone back?
Yeah. Thank you so much. Thank you so much. I take this opportunity to thank the chair as well as all the panel speakers. Continuing further on the same session, we would request all the panelists to kindly stay on so that the second part of the panel will be dwelling upon the other aspect of end-to-end security. Over to Mr. Amit, please. Thank you.
Thank you, Dr. Subbu. So now in this panel, we will focus on end-to-end security in 6G, including network architecture, security data handling, and addressing threats from virtualization, SDN, NFV, etc. I would like to introduce panelist here, Dr. Hemant. He's senior member of IEEE. He has done MTech and PhD from IIT Bombay. He has 25 years of experience in academics, research, and industry. He's a principal scientist here in TCS with us. Second is Dr. Mani. He works as a AGM in NEC. He manages AI/ML aided 5G and beyond related research, ORAN Alliance based 5G solution development, telecom security, involved in 3GPP and cyber threat related intelligence support. Next is Mr. Momba. He is a CTO at Keysight, managing team of industry segment experts in communications, network security, and testing, memory and peripherals, interconnects, and automotive and energy solutions. Next, we have Dr. Debu. He has excellence in cybersecurity management that includes threats, security, and risk. He is associated with various industry forums in India. And from telecom services provider, we have Mr. Sanjeev. He works with Bharti Airtel and manages core network planning, delivery, and security. He is involved in plan, design, and build activities of telecom network infrastructure to identify and mitigate potential risk and threats. So I'll hand it over to Dr. Hemant to start the panel here.
Thanks, Amit. Chandrakanta ma'am, maybe we can present. Yeah. Please go to full screen mode. Thank you very much, Amit, and thanks TCSI for inviting me for this particular session. So we have like four panel members here, and I'll start this context here, and then other panel members will keep on presenting. Yeah, but next slide, please. So, okay, we start with the evolution from 1G to 6G. So we started way back in 1980s, that 1G, and then 1990 with all SMS and other things, but security, little bit of things started. Earlier 1G, there was no security. Then in 3G, we have IP traffic came into picture. So security also started becoming a reality and some issues coming up security. And 4G started in 2010. And there, like you have mark layer security, vulnerability, those issues come into picture. Then beyond 2020, and still like in India and other places like 5G are still getting deployed, we have many different vulnerabilities coming from NFV, SDN, of then ORAN, other kind of things are getting deployed, and we have so much vulnerability coming from the 5G deployment here. And when you go for 2023, that 60 kind of things, so the security will be a major concern from not only from the architecture perspective, it will be there from the application, from the technology, from all other perspective. Like so, we'll see those things in this panel itself. Next slide, please. Yeah, what exactly we see from like the evolutions? If you see from 5G to 6G, 5G we have three kinds of traffic, like say AMMB, MMTC, or URLC kind of traffic. But here in 6G, we have ultra high mobility, ultra high precisions, ultra low energy. Then we have massive connectivity, large coverage, then broadband. Whatever IMT 2030 is talking about, all the things, different kind of traffic, different kind of applications, are getting evolved, and the applications, the technology are getting evolved and getting migrated to that directions. So things will become completely different beyond certain time. Next slide, please. Yeah. So from the QoS perspective, if you see, when 5G talks about 10 gigabits per second, 6G talks about 1 terabytes per second kind of things. And here in 5G, the delay is almost latency is 10 milliseconds, here less than 1 millisecond. And similarly, like here, like the mobility supports by 5G 500 kilometer per hour, here it can be almost 1000 kilometer per hour. Like everywhere, like say energy, then spectral efficiency from 30 bits per second per hertz, it goes to 100 bits per second per hertz. Similarly, frequencies band, like here we have sub 60 gigahertz band, we have millimeter wave kind of things. But here we go for 6G, we go for terahertz kind of communications. And reliability also goes for 99.9999 kind of things with 4 nines. So they're like the extremely high reliable, extremely high secure communications needs to be there. That's the very key challenge, if you ask me, from the QoS perspective. Next slide, please. Now, to realize 6G, we need to have extreme high coverage. We need to have like all kind of heterogeneous communications. We need to have extremely low latency communication, as I said, 1 millisecond or less than 1 millisecond kind of things. Extremely high data rate, 1 terabits per second kind of things. Then extremely high reliability, 99.9999 kind of things. Extremely low energy, and all these things, extreme conditions will be there. So extreme conditions also is applicable for security as well as for privacy. Next slide. Yeah. So from all this deployment so far, starting from 1G to 5G, what we see today, what I have learned, security is actually a afterthought kind of thing. So you first deploy it, then talk about security, but that is not going to happen. See, here today with 6G, the new applications coming, new applications are like going to be compromised if you are not going to talk about the security from the very beginning. And the technology, we have to have improve the technology itself before getting deployed. So whatever 6G technology we are going to have, whether BLC or whether terahertz kind of communications, all kind of things, all physical layer communications, all the things going to happen, we need to have security in place, starting from layer 1 to layer 5. All layers will have proper security. That's the reason end-to-end security is a must condition. Then compatibility is frequently circumvented by requesting outdated architecture authentication. So this is also very essential fact from our learning perspective. Large scale essential equipment upgrades are necessary. So we cannot go back to the say legacy system and talk about 6G. So when you go for 6G kind of things, so we need to have a lot of testing, lot of cross checking of devices, protocols, because the old protocols and new protocols, then there will be some mismatch. And because of that, if you are going to deploy something, and if you go back to previous version, there will be vulnerability, then applications will compromise yours. Through that app, through the device, people can enter to the network and can create a lot of problem. So all the things are going to have like a major concern. Then long-term security has to be a long-term design, like from the 60%. It has to be from the architecture perspective, it has to be there. And then mutual authentications, encryptions, this also will be very essential from the security perspective. Next slide, please. Yeah. Coming to 6G perspective, if you talk about security, for end-to-end security perspective, the three things are essential: the architecture, the applications, then technology. If you talk about architecture, like 6G is like a combination of central, distributed, and a lot of virtual components will be there. You have intelligence in the network management, you have intelligence in radio and edge, all RIS technology will be there. beam farming will be there. You will be having hybrid beam farming kind of technology will be there. A lot of different things will be there. And then applications, we'll have a lot of new applications are going to come into picture. We'll see those things also here. We'll have a lot of enabling technologies like say AI, DLT, quantum communications, all things will be there. And we'll discuss those things in the next couple of slides. Next slide, please. From the 6G architecture perspective, like we have, you see 3D picture of this particular thing. We have a control view, we'll have the infrastructure view, and we have the network view. And if you see from the network view, we have all these PLC, terahertz communications, new technologies. We have blockchain, we have all 6G applications will be there. And if you see from control view perspective, we have intelligent radio, intelligent aids, those kind of things will be there. And if you see from the infrastructure view, starting from space network to aerial network to terrestrial network to all kind of the networks will be there. So 6G networks, like we need to have zero touch security, we need to have zero touch kind of things from the very beginning in the 6G itself going to picture. Next slide, please. And now if you come to applications, we have so many applications going to come into 6G. We have like immersive XRs, we have AR, VR, MR, all will be there, and which will be very much essential for gaming, education, training. We have holographic communications, which can represent 3D kind of things at a long distance kind of thing. It can make very realistic digital avatar kind of things, both immersive AR and other things. We have healthcare with the robotic surgery will be a reality, and we have personalized AI assistants. So many other applications like UA applications, holographic applications, all other things will be there. Like you have digital twins also be there. We have Industry 5.0. All applications will have different threat issues, and we'll see those like which applications will have what kind of issues in the next slide. Next slide, please. Yeah. If you talk about UV based things, and we have ultra this thing like some are in the very medium range, some are very high range, some are very low range kind of thing. So if you UV kind of things, so reliability, other things will be very high, and you need to be very privacy will be very high. And if you go for Industry 5.0 kind of thing, so the ultra lightweight security will be very medium, whereas energy low latency will be high. Similarly, like all applications will have different requirements. So those who are like getting involved in the applications layer security design, whether in standardizations and research aspects, so they will have a much bigger challenge going forward. Next slide. Similarly, for the emerging technology perspective, there are so many technologies, like we will be having terahertz communications, we'll have like holographic beam farming, we will have cell tree MIMO, we have artificial intelligence, we have blockchain, we have zero energy interface, we have new coding techniques will be there. You have multiple access technology, new technology, we have RIS, we have edge intelligence, quantum communications. Like all these are the technologies will be there, and these technology before getting deployed has to be secure, and that all the things has to be tested beforehand. Next slide, please. Ma'am, next slide. Yeah. So here the security threats, if you see from the technology perspective, like simple from the AI or DLT, or like for the quantum communications or terahertz communication kind of thing. If you simply see from AI perspective, we have poisonous attacks, we have compromise of AI framework, we have ML API based like attack will be there. Like we can have significant reductions in accuracy because of all the things. We can have model inversions, we have model extractions, then membership interference attacks. So like these things will be there if from AI, and if similar for DLT, the fake transactions will be there. That is going to compromise on the blockchain, other things. Similarly, quantum communications, we have quantum cloning and quantum collisions will be there. I think a lot of research is there in that directions, but you have to be very secure before getting deployed, because if we the technology is very different, and if the deployment is not appropriate, then the low latency communications which we are going to 6G is going to target is not going to be there all the time. Similar terahertz communications, you have access control and eavesdropping will be there. That is also is there in the VLC kind of things also. Yeah. Next slide. So the like as I said, set the context here to go further in the in the different directions, starting from ORAN and in other directions, quantum, all kind of security things in the next couple of presentations from my panelists. Thank you.
Thanks, Hemant. This was very insightful, especially the security challenges with the previous network technologies and improvements with the evolution. Let's hand it over to Dr. Mani now for next 7 to 8 minutes. Dr. Mani.
Hi. Yes. Greetings, everyone. Thanks to TSDSI for giving the opportunity to present. Next slide, please. So in the earlier presentation, Dr. Hemant mentioned about the intelligence radio and edge. So here in the end-to-end network, I'm going to do little focus on the initial part of it, which is the RAN networks, and how ORAN Alliance plays a significant role in bringing in to enable for the 6G networks. Starting from 2018, now with 300 odd participants, this ORAN is setting up the standards to make the open and intelligent RAN. So this is done with the help of publishing specifications which are open to public and accessible and downloadable. To kickstart your activity, ORAN Alliance helps in providing reference software via its ORAN software community. The specifications from the ORAN Alliance is done accomplished with the help of 11 work groups and 6 focus groups. The details are available in these links that can be accessed by the people. The next slide, please. So the ORAN Alliance, while it focuses on the RAN networks, it's not siloed. It is walking in step with the 3GPP specifications in terms of enabling innovation and collaboration. If many of you might recognize in the until 2G, 3G networks, there was a controller in place for the RAN, whereas in 4G, there is no longer a controller, and then solutions came in terms of SON, self-organizing networks. Now, with respect to bringing in the ORAN concept, we can bring in RAN intelligent controller, both in non-real time and near real time, to make the RAN network very intelligent and make it optimal and efficient. In this slide that you see is how in the distributed RAN, which is the CU, CP, CUP, DU, and the radio, the ORAN interfaces playing the role along with the 3GPP defined interfaces. So the service management and orchestration orchestrates the various elements. Along with it is the non-real-time RIC and the AIML model related part, which is provided to near real-time RIC, which in microseconds or less than milliseconds configures the CUCPs DUs to have efficient radio access networks. Next slide, please. So AIML plays a key part, that is one of the founding aspect that has been considered in ORAN. So if you take the telco network, you can see it in a three-dimensional view from like a prism. One is the operations, where Gen AI based approach can be used to help in your operations. Your machine learning algorithms can help in to do efficient radio engineering and other aspects, and then your knowledge can be fully leveraged. So as I mentioned earlier, the ORAN and 3GPP are going hand in hand, so certainly to make it overall successful. So if you see the SA5, which is the management led function in the 3GPP standardization body, the ORAN ORAN interfaces definition, which is again in handled in different groups, takes care. The NG-RAN, which is led by RAN3, again here the work group 11, as earlier Mr. Vipin mentioned, the ORAN security works along with it, and SA2 led, there also we have the role to play. So this slide basically captures you from in the telco, there are various ways in which the AI is put in place. ORAN, Open RAN, in the ORAN Alliance, we keep a special emphasis for bringing in AI ML, and that is also aligned with the various 3GPP work groups. Next slide, please. So this slide basically a summarization for a RAN network. There are three different ways in which you can have AI ML model. The traditional models, traditional ML models, you have the reinforcement based learning models, and lastly, the one which is taking by storm, the Gen AI models. So applying suitably the multiple models, you can bring in an efficient and intelligent RAN. That's the key takeaway from this slide. Next slide, please. So this slide dives little deeper in applying the generative AI and using the large language models, which is the most everyone tries to leverage. How do we do it? So it could be help to make various scripts that are being created, helping in various documents being generated, help to analyze the root causes when you have large amount of data that come in from network elements, to predictively forecast what could happen and prevent any issues. Now, we can also combine it with your reinforcement learning, especially as initially said, when you want to do efficient slice design of your end-to-end network slicing design. How do I slice my network and how do I have it optimized? The energy efficiency is a key aspect that is being discussed, and how do you bring in energy efficiency? Always we know optimization. How do we optimize my network? Which is when you do the network slicing, again, you could turn on and off your radios, etc. And your network planning. You can have your agents that can be a self-healing agents to handle various issues, and also generate basically aspects and solutions to handle it. So this slide basically is a view of various applications that could be done with Gen AI for telco. Next slide, please. So when you have a huge AI ML in place, already it was touched upon. So what Moran in Moran, in the security working group where I have the opportunity to contribute and present, we have a focus on mitigating various possible attacks. We have done an extensive threat analysis of the AI ML that is possible in the Open RAN network, also extending to the 3G. So the left-hand side diagram basically is a flow, how data is taken in and how it is being modeled, trained, and used in inferences. So we have currently identified broadly 12 possible types of attacks that could be on the identified assets that would exist in an intelligent Open RAN network. So the details of this are available in the publicly accessible technical report. Now, last but not the least, we have the security, a strong security organization, which is MITRE. Many of you might have known. They have a threat model called Atlas. This is the adversarial threat landscape for artificial intelligence system. How various attackers would attack in various steps and how you could identify and mitigate them. Next slide, please. So while in the earlier slide, I mentioned about the possible attacks. The attacks happens either from the external users or internal users. So the key to bring in is to ensure that it is not possible either for them. How do we achieve it is the zero trust architecture approach. So in the ORAN, when we create the intelligent networks, ORAN Alliance is applying zero trust architecture to every aspect. The NIST defined zero trust architecture has 7 tenets of zero trust. And due to focusing time in concern, I'm not reading it through. These 7 tenets puts together ensures every resource is protected, every user can have access only when needed, and not only that, there is a continuous monitoring aspect that ensures that the security is maintained. Making the zero threat, you start with a model. So there is a maturity model. People have security in place, but you move from the traditional model and then you move towards an optimal model applying the zero trust principles. So Oran has published recently a white paper capturing this particular part. The next slide, please. So the next slide basically says how everybody come hands together, right from the academic institutions and various aspects who pave the way for innovation, the regulatory bodies defining the requirements, and the standard development organizations, the 3GPP, TSDSI, everyone coming together trying to make the 6G a reality. So this is a broad timeline that is being looked at. And the next slide, please, which concludes here to say to make the end-to-end efficient for 6G, AI ML has a key role to play. There are threats which are being identified and mitigations are studied. How to handle them to tackle both internal and external threats are being looked at using the zero trust architecture, and all the standard development organization come hands together to make a successful 6G requirements and enable its implementation and deployment. Thank you for your attention.
Thanks, Dr. Mani. Now we invite Dr. Debu to talk about cybersecurity for next 5 to 6 minutes.
Good evening, Chair. And I want to thank Madan sir for giving the opportunity. And also I want to thank TSDSI for giving the opportunity. So in the constraint of bandwidth, I will just switch off my video, and then probably I will talk what exactly need to be done in terms of cybersecurity when actually we are doing for 6G security aspects. So there will be a lot of changes will be happen in the 6G architectures. 5G architectures will be go to like cloudification, service-based architecture, and it will also have a lot of changes will happen based on the API calls, and the integration will happen when there will be different kind of protocols will operate in the different interface levels. So there is a dramatic change will happen in the 6G security architecture, what has already been discussed. And security architecture will revolve around 5 or 6 parameters, which is currently the work items, and they have been discussed in 3GPP, 8C. So all this discussion is happening. One we call as 6G zero trust architecture that will really define how actually will make 6G to be self-reliant. So the second thing is we call as a 6G as a network as a service, which was not in the case in case of 4G and 5G. So that will give a paradigm shift in the security aspects. And the third thing that will we found out that the user plane microservice and the control plane microservice that need to be secure, which was very, very difficult when actually we go into the telecom service provider layers and to do all this microservice segmentation. And in terms of slicing also, if you see the slicing in the 5G, you have a slice template. In the slice template, to secure the slice template, it takes a lot of effort. So similarly, when you go to the microservice level in 6G to secure it, it will take a lot of effort to find out what is the encryption algorithm that need to be used, what is the authentication algorithm that need to be deployed. So currently there is a discussion going on that they call it as a lightning authentication and a fast encryption techniques. So those are the techniques has been discussed, how actually they will be used in the 6G context. And the most important thing is since 6G will revolve around the service-based architecture, so it will revolve a lot of policy-based configuration. When the policy-based configuration will happen, they will based on the lot of AI and ML algorithm will take place. This AI and ML algorithms will have its inherent flaws. For example, what is the security challenges will happen in AI and ML algorithms, like it do not have a much clarity and visibility, and the trustworthiness is also a key factor because it depends on the geopolitical scenario. If a country is a democratic country, the algorithms developed there to run in the equipments to do this all kinds of work, that depends on the way actually these people are defining. But is this the country, is the autocratic country who defines the artificial intelligence, who controls the large language models, in terms control the algorithms and goes to the neural network and put the data sets which are already biased based on their requirements? Does that will really suffice to serve the purposes? So these are all these things that need to be taken care. And because to do all these things, there is no ethical and legal aspects is available currently in the uniform ethical and legal aspects. Every country is now working with every other country with the bilateral agreements or multilateral agreements. We do not have a global artificial intelligence based regulatory framework that will cater all these issues that will comes into picture. And there are attacks will also happen, and which has been like API based attacks, poisoning attacks, or we have large language model based attacks. But one of the great thing is that NIST has come out with a methodology how to test these large language models. For example, our telecom operators are very good. They are testing the telecom networks based on the VAPT. They are doing regular quarterly audit of VAPT, and then they are finding out what are the equipments they are deploying in the field. And when they will do the VAPT, they will find out, okay, so these are the vulnerability will exist in my network and fix it, and based on this. But what will happen if the large language models do not have the testing tool to test it? How to find out these things? What my friends have already told, that your ORAN or your RAN portion is totally AI based. Your code is also AI based, and your service based architecture or your maintenance, operation maintenance, automation, everything will run on AI based, and that will comprises of large language models. And these large language models, how actually will test it? Do you have a test tool like DDoS? We are testing by NetScout, web, email, or network DLP by ForcePoint, or proxy by some kind of Imperva, or NIPS by Trend Micro. We have a set of tools which is currently used to test it. But to test all these factors in terms of artificial intelligence models, large language models, is a huge and cumbersome task in terms of 6G networks. So that need to be refined. And the last point I just want to find out that 6G is working a very good solution, what is called as self-healing mechanisms. What is actually a self-healing mechanism means? You have a human body, you have a cold, you have everything will happen. We do not take medicines immediately. We wait for 2-3 days and say how the human body works with and do the self-healing. If it does not works, then we go for the doctors. But similarly, 6G is developing the criteria how actually it will auto heals, how it will self heals the security attacks and take the remediation in the fast go. So those kind of things are inbuilt coming in the 6G parameters, and based on this you will find out how actually the remediation will happen. If it does not happen, then it will take. But at the end, I just want to tell all the policymakers, the regulators, please work with the telecom service providers, because they are in field. They are actually implementing the networks. We can bring. I was going to a particular country in Europe, and I asked the telecom operator. He told, "Look, Dabu, we are regulation says that we must do a penetration testing in the live network." I say, "Have you done this?" He said, "No. How can I do pen test in my live network?" So we can bring a lot of regulation, but if it is practically not feasible for TSPs, because they are the people actually providing a lot of services to the common man. They are actually giving the lifeline to us during COVID times. So we must consider the importance of TSPs and the telecom service providers, and the regulators and the policymakers should also consider the intrigues that will come in the 6G network. And based on this, we must see how we can work hand to hand, and together we can build a great nation. Thank you.
Thanks, Dr. Debu, for insights on threats, security, and risk. and your wonderful experience in this journey. Now, I would like to invite Mr. Momba to give insights on network security and testing scenarios for 6G.
Thank you, Amit ji, for having me. Thank you, TSDSI, for this invitation. I will need 7 to 8 minutes to finish my presentation. What I'm going to talk about is what's actually happening in securing the networks, and what are the remedial measures that actually you have to take in case there are breaches. Next slide, please. Yeah. So, traditionally, when the networks start evolving, the first and the foremost protection that we started with was firewall. So, what does firewall do? It filters incoming and outgoing traffic as per previously established policies. This is how it started. Next slide, please. But it immediately expanded into a lot of point products considering the need of the emerging network. So not just firewall, but we had different tools available for securing the network, including intrusion detection system and protection system that you see on the screen. So detection allows you to detect the traffic and then leave it just like that. Protection actually allows you to accept and reject the packet based on the rules, and they are frequently updated as well. Okay, the rules are frequently updated. Gateway antivirus actually allows you to scan computers, devices, and gateways for any malicious traffic or any other threat that you can see through coming to the network. Now the actions can be quarantine or removal or reporting back to the user. Okay, the other one is proxy. Now proxy is frequently used. What it is used for? It is used for providing a shield between user and internet by providing an intermediary to prevent the cyber attacks. What is very important, what has taken shape recently, is the application ID. This is not Apple ID, this is application ID. It provides visibility and control over applications that can evade detection by masquerading as the genuine traffic. Okay, and it can happen in several ways. We'll not talk about the intricacies. There are other tools which are also based on SSL or SSH, wherein you provide traffic through security through certificates or through creation of tunnel. And lastly, the VPN, which is again a tunnel creation between user and the network to hide the activity and the location of the user. But this is what we started using. Next slide, please. And it worked well till the next network expanded into what we call it as a cloud and a user based, because we started putting the host of information on cloud and the user became mobile. So these things were started getting distributed both in terms of data center, public cloud, and the user as well. Next slide. The implementation of this, next slide, please. The implementation of this changed as we evolved in this architecture where we have cloud-based and the database services. The protection mechanisms were rendered through hardware, software, or a bouquet of services, which can be combinations of several of these protections in what we call it as SDP, or software defined perimeter. The security stack, which is also a software access service edge that you see on the right side, is basically a service rendered through SaaS, wherein you can have the combinations of these security shields providing the security. So net, you can have these securities implemented in hardware or software or services, either in the data centers or the cloud or in the devices which are using it. Next slide, please. Now comes the question as to who own this responsibility of providing the security. Let's look into the cloud. Cloud service providers provide cloud native security solutions. They do not own the security solutions of the entire network that we have seen in the previous slide. So there are several ways in which they achieve it. All the big company names that you see on the screen are protecting their own network. They safeguard with combinations of several of these security features that can exist. Next slide, please. Next slide. Yeah. But that's not the end of the story. While the cloud is one part, the provisioning in the network is now very dynamic, and that is being done with SD-WAN. Most of the enterprises are doing it with SD-WAN because it is dynamic. They have to automate and provision with the programmability that can meet the needs of enterprise in terms of connectivity and circuits. So if I see the architecture today from top to bottom, it appears to be a connection of cloud to edge. It's not just connection, it's a continuum of cloud to edge with interconnected nerve cluster, and these nerves can keep on changing as we dynamically provision it, and that makes the security protection mechanism to be more controlled and precise as we move forward. So the evolution of the network is continuous. It is not static. And whatever safeguard that we do in the network would be valid for the kind of provisions that we have made for the network. It need to be upgraded. And we have to have a good security posture. Next slide, please. In terms of what we are doing in India, okay, let's look at what can be an impact here. Okay, so look into the chart here. We are staring at a situation wherein we can have cyber attacks, and this is not a kinetic war. In kinetic war, the adversaries is known. In electronic warfare, the targets are known. But this cyber warfare or cyber attacks, you do not know who the enemies and the targets are, and it is basically kind of a cold war that we are reminded of. Okay, and our preparedness for this kind of cyber attacks are required. If we see a condition in India, of course, it's little older data, but things have not changed much. Most of the protection is done by the developed countries. We are not there in the top of the list. Next slide, please, as a country. Yeah, next slide. So, yeah, next slide, please. This is where India is still. So what do you do to circumvent this? And that is to test. And there are reasons to test. I'm going to talk about IoT devices more than the general network because we are talking about 6G, and 6G is largely based on, use cases of 6G like holography and sensing, or the other applications which are requiring a lot of AR, VR, a lot of reproduction of information which are data driven, are also having a lot of IoT devices, and these IoT devices are quite vulnerable. Okay, these are at risk. 87% increase in IoT malware has been seen in recent years, and 98% of the traffic sent by IoT devices is unencrypted. Now that brings a big worry. Most of the organizations concentrate on the network and they don't worry about the IoT devices much because there is a dearth of information and skills in the industry. Next slide, please. So there has been instances, and they are real. I won't read all the instances. They are big macro instances in which there were breaches in IoT attack. And what does it lead to? It leads to financial loss, not just financial and the reputational damage of the company or the enterprise or the country, but it also has a far-reaching ramifications in terms of psychological impact of trusting the whole network. So there are breaches, and these breaches had taken some toll. Next slide, please. So what are we doing about it? We need to do the testing, and there are certain aspects of testing. If you are involved in the testing, you have to look forward to testing several things. Okay, first is make sure that you test the details on premise as well as on cloud. So you need to have the test feature like that. You test proxies very well because this is a shield that most organizations most of the enterprises are using as the protection. Elasticity, the scale with which we actually build the organization, the scale with which we ramp up, the scale with which we configure has to be accommodated in the test feature that we have or the test vector that we develop with the testers. And the actual realism of traffic, that means we need to have the protocols, traffic, different combinations of traffic, and then also the throttling of traffic that we have in different combinations as a traffic realism. We also need to do the identity based authentication. We have spoken about authentication in the past. And then, of course, distributed network throughout the globe, because we don't have any kind of physical boundaries of these networks. So some of these things are required. And next slide, please. Security is a subject that is seriously taken up at a global level. Standard bodies are looking at it. They are formulating standards, but standards is one part. Okay, preparedness is one part. There is always going to be some rogue actor somewhere who will try to breach, and the emergence of AI and quantum will be further aggravating the situation. Why? Because they are as fast as what we do in use of AI and quantum. So if you use quantum computing for fast computing, a rogue actor can also use the same quantum computer to scan through the entire network and figure out the vulnerabilities and attack faster. Okay, so when you get into a world of computation, faster computation and bigger services, you're staring at bigger situation. But we are getting prepared with time. There are agencies like CISA, and also Manikantan spoke about MITRE. They are taking some actions. CISA provides guidelines, MITRE provides actions. And then there is a federalism of what we call it as common vulnerability exposure. These enterprises are exchanging vulnerabilities amongst themselves, and the repository is available. At Keysight, we have the access to it. We add it in our own tester every fortnight. But what it means is, if you are running an enterprise, you need to actually also add the common vulnerability exposure and make sure that these are added in the firewalls or IDPs and other gateways, so that you safeguard your network. Lastly, I just want to say, India also has a good preparedness. We also have Computer Emergency Response Team, that is CERT. CERT-IN is what we call it. In case vulnerability is found or detected, they get into action and try to safeguard our country as well. While in 6G, the architecture will change, not drastically, but it will change in terms of both access and core. But what will not change is our preparedness and the way in which we provide the security shield. So, ladies and gentlemen, thank you for your time.
Sure. Thanks, Mr. Mamba. Interesting to note that security is not an option, it is must. I'll hand over the last session, very important session from telecom services point of view. Mr. Sanjeev, floor is yours.
Yeah, thank you so much, sir, for extending this opportunity to talk on this particular session. Chandrakanta ji will be moving the slides. Yeah. So I'll talk about how network security is evolving with the every generation of mobile technology. There is an evolution of security. While we grow from 4G, 5G, and 6G, there are adaptation of new technologies, which includes application onboarding on standard OS, which used to be a customer-specific OS in the earlier times. Cloud virtualization technologies have taken over for onboarding of application, which used to be on bare metal. And there are a lot of automation tracks which are moving as part of onboarding network infrastructure as well as application ecosystem in the telecom network environment. Network is getting exposed to the open interfaces, and your perimeter of network is getting expanded. So threat actors also, the motivations to the threat actors is increasing on the telecommunication network. Now, telecommunication network is nowadays very, very critical. It is as good as actually a utility service like water supply or electricity. A telecom network is down or sabotaged, it actually can impact the nation so badly. The attacks are actually getting sophisticated. So with this particular evolution of new technology, threat actors, and the highly sophisticated attacks, our threat landscape is increasing in the mobile telecommunication network. The threat privacy as we do evolution of different enterprise use cases, apart from a normal B2C use cases, your privacy protection, your data protection requirement, as well as the regulations are growing. The sophisticated cyber attacks, which includes AI-driven attacks for quantum computing, we just talked about the fellow speakers in the earlier sessions. Slice isolation and the security threats in the slice isolation. So we are going to create different slices for different application, but inter-slice isolation or pilferage from one slice to another slice is another threat landscape while we do evolution from 4G to 5G and 6G. Supply chain threats are a major concern, although we are now taking some key steps in terms of a trusted source and a trusted OEM in terms of onboarding a network element in the telecommunication network. With the IoT evolution, there is an increased possibility of massive denial of service attack on the telecommunication network because this acts as a botnet army and can controlled by a command and control center. Yeah, so these all actually lay down the foundation how the network security is evolving. Can you go to the next slide, please? Now I will touch upon that what is the kind of security approach a TSP or we are following as part of onboarding our application or product. While there are a lot of advancement happening in the technologies, there are adoption new technologies, these standards are being written as part of security requirements on the network nodes. But if these requirements are not implemented properly in the production network, it is of no use. So what we do as part of this, as part of initiation of any product onboarding or any network equipment onboarding, we capture the security requirement along with the functional requirement as part of the onboarding network. So there are 5G network elements and associated security requirement written in the standard and the 3GPP also. But as operator, when you onboard these network element, if you don't include the compliances required around this supplied equipment from OEM, it doesn't make sense. So we capture well in terms of security requirement along with the functional requirement as part of onboarding a product. Then as part of deployment, whatever the control which are mandatory as part of hardening of the system while you put into the production network, we have to harden the systems as part of onboarding the network. So that is the second step which is being followed as part of the security by design approach. The third part is while you do the implementation, as we do the functional testing of a product, the security testing of the product is equally important as part of accepting this product in the production network. We earlier prime focus of putting a network element into production network was doing some acceptance testing, do some functionality, do some load testing, but security was not actually given attention. But with the increased requirement of security, with the criticality of security in the telecommunication network, this is very, very critical. So as part of onboarding a network element, security acceptance testing is conducted. Vulnerability assessments are also conducted, and the respective vulnerabilities which are reported are being mitigated to much extent or agreed upon a clear action plan that one, it is going to be mitigated in the next upgrade cycle, etc. Right? User access management, what all user will have, what kind of segregated access profile on the respective network element. This is very, very critical. Then during the operation state, we do the security monitoring implementation as part of network SOC. What we do, we define the respective threat modeling of respective network element, what need to be monitored. If something happens bad in your network, what kind of information you are going to process from your security logs, and build a monitoring use case in the SOC so that you can detect and act immediately. Then you define your incident response plans accordingly. As part of operation, you have to conduct security risk assessment on a regular frequency basis. Whatever security risks are prevalent as of now cannot be a state of same affairs down the line after say a couple of months or 2-3 months. So security posture changes so frequently that you need to continually or at a certain frequency do the risk assessment of your network, what all risk you have, and then define a security roadmap. And as part of offboarding, you have to ensure that the respective customer sensitive data or some privacy data is being degaussed or removed properly while you offboard a network element from your network. So this is the journey from initiation of a network element or a product into your network from disposal. Can we go to the next slide? Now I will touch upon what are the key work streams which are critical as part of managing security of your telecom infrastructure. Firstly, I discussed about security risk assessment at a certain frequency is very, very critical. While there are changes happening in the processes, while there are changes happening in the technology or new use cases, or there are some new techniques coming out in the market which can compromise your network or the network element, which earlier was not possible. So continual security risk assessment is very, very critical as part of assuring the network security. And as an output, you define your security roadmap, that what all process correction you need to implement in your system, what all new technology onboarding you need to implement, what all additional security controls you need to implement on your infrastructure. That is part of security assessment. Then as part of security risk governance and compliance management, it is very critical that whatever the network ecosystem you have, now you need to ensure what all controls you lay down to be ensured and implemented are actually being followed by the respective stakeholders managing this infrastructure. So what we do as part of security risk compliance and governance management, we maintain a GRC dashboard wherein all the controls are mapped to the respective stakeholder and the node owners, and a compliance mapping is being done that these processes, for example, there is a process of monthly user validation, that whatever the user have access to the network are being validated. Then it is being reviewed with the team that it is happening on the ground or not, or team is just has not done from the last 3-4 months. That is one example I'm saying is one control wherein compliance is being monitored. Second is regular vulnerability assessment is being done so that any new vulnerability which are coming out are being addressed promptly. Compliance to your contractual requirement, compliance to the regulatory requirement are being measured and see are we compliant. If we are not compliant, what systematic and incidental fixes we are doing in the system as part of maintaining the compliance. Then security of processes, there are user access management, there are firewall management process, there are encryption management process. All these different processes are defined and they are regularly updated as part of security operations. The last is setting up the security monitoring and control center, wherein you capture all the log sources, you build your threat monitoring use case, and then you monitor anything bad is happening. You have a digital forensic setup. As part of it, any incident which is reported, you do an in-depth analysis, what went wrong, how you map the audit trail, and then we define incidental and systematic fixes. Then security automation, as part of security automation, what we are doing is any incident which is reported, it is given to the security automation platform, which does two parts. One is it captures the additional log information in an assisted manner, in an automation manner from the respective network node element and present to the threat analyst. That cut down the incident analysis time. Second part is if you need to do an action immediately, for example, if user has done some malicious activity or some reconnaissance is reported at firewall, you can immediately instruct your automation platform to put a policy in your user access management to block the user or put a hardening policy to block that particular IP for being communicating. So these are all the work teams which are very, very critical as part of managing your security of telecommunication networks. I end my presentation here. Thank you so much.
Thanks, Mr. Sanjeev. So we conclude, the two panels here, and this session was focused on 6G security and privacy. And we had two wonderful panel discussions that deliberated on two aspects of quantum technology in the context of 6G and end-to-end security. So the second panel also brought out the opportunities towards leveraging AI for network intelligence, zero trust principles, and privacy enhancing techniques across the sectors. With this, I would like to thank everyone, TSDSI organizing committee, especially Madanji, Chandrakantaji, my co-chair, Dr. Subbu, panel chairs, Professor Anil, Dr. Hemant, and esteemed panelists, Anindita, Prashant, Vipin, Dr. Mani, Momba, Dr. Debu, and Mr. Sanjeev. Also, the lovely audience for taking out time for this important session. We are going to have two important sessions tomorrow also, 18th of July. Session 5 will be focusing on spectrum aspects for 5G Advanced and 6G. This will start from 2 p.m. to 4 p.m. Indian Standard Time. Then we are going to have next session, number 6, that will focus on rural broadband technology landscape. That will start from 4:30 p.m. to 6:30 p.m. Indian Standard Time. With this, thank you, everyone. Thanks for attending the session.
Thanks, Amit.
Thank
Cheers. Thank you, panels. Thank you, audience.
Thank you, sir. Thank you,
very
Chair.
much.
Thank you, everyone.
Thank you, sir.
All right.
Thank you, sir.
चल चलिए